In the last video, we introduced the Titanic dataset and filled in all the missing values. So now we have the dataset here with no missing values whatsoever. So what we will do in this video is to continue a bit with this pre-processing step. So let's take a look again on the Titanic dataset. Just the 10 first rows. So here we see the dataset and we have a lot of different columns here. And a lot of the features is actually duplicated. For instance, the embarked and embarked town gives us exactly the same information. Here we just chose to represent the cities with a letter instead of the full name. So before we do machine learning, we need to clean it up a bit. So let's remove some of the duplicated information, and we can do this with Titanic.drop to drop some of the columns. And then we need to write in which columns do we want to drop in a list. So let's see here. We want to drop this embarked column because it's also contained in the embarked town. Next, we have two features that tells us the class of the passengers. Additionally, the who column is more or less contained in the sex. Adult male is more or less also contained in the sex of the person. And also alive is contained in the survivor column. And I also write in place equals true so that we actually do the replacement. So now something is wrong and I have written embarked wrong. It's spelled with a K. So let me try once more. So let me also print out the head. And now we see that we have a lot of fewer features because we deleted all the repeated ones. Okay, so the next one is that we have this sex column, and here we have male and female categories. Before we take it into our machine learning model, we need to take these categories and making them into some kind of numbers, because our machine learning model works with numbers and not categories. So what we will do is to create a new column here, which is 0 if the passenger is female, and 1 if it is a male. So let's do that. So we will take the Titanic dataset and make a new column, which we call is male. And this is going to be equal Titanic. And then the sex column dot replace. And inside replace, we can provide it with a dictionary. So we want to replace female with 0, and we want to replace male with 1, and I misspelled sex here. So it will take the sex column and replace all the females with 0 and all the males with 1 and save it in a new column here. So let's run this cell and let us also print out the head. And now we see that we have this new column here, which is called is male. But we still have the sex column, and now we have some duplicated information. So we want to drop it. So let me write drop again. And this time we will drop the column sex here. The Titanic dataset is not now changed because I forgot to write in place equal true. So now it have actually changed the Titanic dataset. So it might happen that these features here are completely useless in determining if a person has survived or not. And if that is the case, we want to remove it so it doesn't confuse our machine learning model. So let us do exactly that. And first of all, I want to see which features are correlated with the survived column. Okay, so here we have that, of course, survived is correlated with survived. P-class is actually very negatively correlated with if the person survived or not. Age, a bit, but not as much. This sibling spouse is not very much. The fear price is quite correlated, but it's probably also correlated to the passenger class, so that might explain a lot. If the person was alone or not is actually quite significant to if the person survived or not. Also, being male is negatively correlated with surviving. So, sorry guys, you won't survive. Okay, so here we see that some of the features are horrible when it comes to predicting, and some of the features are quite good at predicting if the person survived or not. So what we want to do is, for instance, the sibling spouse, or the age, and the parage, we want to just remove them so that it doesn't confuse our machine learning model. And also, I will remove this embark town because I do not think it's significant. It might be significant, but we haven't really learned how to deal with these kind of multiple categorical things, so I will drop it here for now. Okay, so let's drop some columns. So Titanic, our favorite drop function. And this time we are going to drop some more features, which is age, sib, sp, and I also want it to be a string, parage, and embarked town. And as always, I will set in place equals true, so it actually does the replacing. And apparently I have no mistakes, so let's look at our dataset again. And here we see our final dataset. So here is our Y column, and we are going to set these 4 columns to be our features. So in the next video, we are going to learn how to normalize the model using the standard scalars. So see you again in the next video. Hi, and welcome again to another coding video. So in this video, we are going to learn how to use the standard scalar transformer on our dataset. Okay, so where we left off was with the Titanic dataset, and we have not yet divided the dataset into targets and features. So let's start with that. So I will say that my target, which I will call Y, is going to be Titanic, and it's going to be the survived column. And the features is going to be everything else. So we will use the drop function that we explored a lot in the previous section, and we are going to drop survived column here. So here we have our target, and here we have our feature. So one thing you should note is that the alone column is a Boolean value, so it's false and true. The Scikit-Learn will send automatically this false value to 0 and this true value to 1. So we do not need to change this feature, we can just plug it in into our machine learning model. So now we will take this feature here and we want to use the standard scalar on it. So one important thing is that we cannot take this x and scale it right away, especially if we want to divide it into training and testing set. This is because if we do this, we will end up with some data leakage, because how we scale this x here is affected by what we will set to be the testing set. We should never let the model learn in any way, shape, or form by using the testing set. So we need to divide into xtrain and xtest. And we are going to use the train test split function on x and y, and we are going to set the test set to be 1/3 of the data. And if you want the same thing as me, we are going to set the random state to be 32. So let's run this cell. And now we have divided our dataset into training set and testing set. Okay, so now we are finally ready to use the standard scaler. So let's import it. So from Scikit-Learn.preprocessing, because it's a pre-processing step, import standard, and let me complete it with a tab and run this cell. So now I need to create a scalar object, which I'm going to call scalar, and it's going to be standard scalar and just initializing it. And this scalar here, I'm going to fit, and I'm going to only fit it on the training set. As I said, if we also use the test set, then the test set is going to influence our machine learning model, and we don't want that. So let's run this cell, and now our scalar has been trained. And to see that it actually has been trained, we can write scalar.mean, and these numbers here are exactly the mean of our training set. So the first feature have mean 2,3, the second feature 32, and so on. So the scalar uses the mean to do the normalization. So that is why the mean of the training set is saved in the scalar. It also uses the variance, and this is also saved in the scalar. So here we have the variance of all the 4 features. So in some ways, the scalar object here has forgotten everything about the training set except the mean and the variance, and it uses the mean and the variance to do the transformation. So now we can actually scale the training set, so let's do that. And we will also need to scale the test set, because otherwise the scaling for the training set and the test set will be different, and we cannot use the model. So the scalar has the transform method, and we can use it on the test set, and we can also use it on the training set. And we also need to actually save it, so we will write test scaled for the scaled version of the test set. And let me copy this part. And here we will write train instead, because it's the scaled version of the training set. And now we have done the scaling part on our features. So let's check out how the training set look. And we see that we have gotten a NumPy array, and it gives us a lot smaller values than what we previously had. For instance, this here was how much the fare costs. And we see that here we have very big number, for example, 53. And here it has been normalized to mostly be between 0 and 1. Now we have trained the test set and the training set, so let's do what we always do with training a model and then testing how well it performs. So let's do it with logistic regression. And it's going to be logistic regression. And we are going to take this logistic regression model, and we are going to fit it on the scale version of the training set, and y train like this. And now we have trained the model. And to get the accuracy score, we can do as we usually do with log rank. And then we can apply it to the scaled version of the test set. And we need to use the predict method. So here we have the prediction. So let us save it as ypred. And now we can use the accuracy score with ypred and ytest. And here we have the accuracy score for this particular model. So now the question is this accuracy score any good? Well, I will argue that it's not very good. And the reason is that if we look at the Titanic dataset again, and we look at the survived column, and we take the mean. So what we get here is that the mean is only 0.38. In other words, only 38% of the people survived. So if I take 1 minus, I will get the percentage of people that did not survive. So that means that 61% of the people, or almost 62% of the people, did not survive the Titanic accident. So what we see is that if our model just assumed that everyone died, regardless if the person had a good chance of surviving or did not have a good chance of surviving, then we would get 61% correct. So that means that our model is just about 15% better than just saying that everyone died, which is not that good, or at least not as good as it could be. So what you see here is that using this standard scaler can be a bit tedious. So what we will do in the next video is to introduce an easier way to kind of collect all these pre-processing steps together with the model to make life easier. So see you again in the next video.